Hi, I'm Param Singh. Hope you guys are doing well. In earlier videos, we learned about a compound data type called tuples and noted that they are used to represent information where multiple pieces naturally belong together. For example, an object in space may need to be represented by x, y, and z positions in Cartesian space. And these three values, naturally go together. And tuples are a great fit for that kind of a compound data. One disadvantage of tuples is that the values are not associated with any field names. What that means is a user has to keep in mind what does the first value represent and what does the second and third and so on values represent in a given tuple. It is not too difficult to manage that when you only have two values, but three or more it starts to get complicated. So oftentimes we want these individual values that comprise a compound data to have named fields, and this is where structs come in. So structs are used to model the compound data. That means the data where there are multiple pieces of information and they naturally belong together of fixed size. So we know that a data set has two pieces or three pieces, known pieces of information, and we want those fields to be named. So this is the key difference between a tuple and a struct, that we need to have names for those fields. Recently, we also learned about keyword lists, which basically are lists of tuple pairs. And now we are going to leverage that knowledge of tuples as well as keyword lists to create our structs. So how do you create a struct then? That's the next question. So you are inside a module. You have to be inside a module because structs can only be defined inside a module. So once you are inside a module, you start with def struct space and then field name colon default value if it has any, otherwise you can say nil, comma, and then you can continue adding additional fields to your struct. So a struct can only be defined inside a module, and another point to remember is that a module can contain only one struct. And this is why I have underlined this, because when you have defined the struct, later on you will be creating a struct from from that definition, and you will use the module name to create the struct from these definitions. So in this particular example, we have a module called t, and then if we create a value that is of this type t, it will be percent name of the module, curly braces, and then you can put some information in that based on these fields. So if you don't present any information, the default values will be used. And if we do present the values, then those values will be used. For example, we have percent %t f1 colon val1. That means val1 is associated with field 1, and then similarly val2 will be associated with field 2. Let's look at some concrete examples. If I say def struct x colon 0, y colon 0, I'm saying that inside my module I'm creating a struct with two fields. The first field name is x and its default value is 0. Second field name is y and its default value is 0. Then I can create any number of structs based on this data structure. For example, p1 percent and then point. This means my module name was point, and then curly braces x 2.5 comma y colon negative 3.2. So I've defined a point with a specific x and y values. Another example is def struct first last manager salary. So this could represent an employee, and all the default values are set to nil. And then we create a concrete structure called GIA, and we start with percent, name of the module, curly braces, first GIA last Campbell manager Jenny. And note that we have not provided the salary, so this will be set to nil. So this will still be a part of the structure called GIA, and the salary will be nil. So once again, when we want to tease out different components out of our structure, we'll use pattern matching. So the pattern on the left hand side of our match operator in this case will be percent, name of the module, that will be the name of struct, and curly braces first colon first. So this is the field name, and this is my variable that I want the values of the structure to be bound to. So last is the field name, and the last here is the variable. Salary is the field name, salary is a variable. If I say equals GIA, this match will attempt to match this structure, and it does matches. So what that means is the variable first will be bound to GIA, the variable last will be bound to Campbell, and the variable salary will be bound to nil. In the second example, we are saying the point structure equals P1. That means X will be bound to 2.5, and then Y will be bound to negative 3.2. If I omit the name of the struct and just say percent curly braces, this will result in a match error because we don't know what is the name of the struct here. Another way to extract the component values is using this dot operator. So if you have a struct called P1 and it has a field name called Y, in this case we have a point P1 with a field name Y, and I say P1.Y, I will get a value of negative 3.2, and it will not be bound to any variable. If I want to update the value of struct, I will start with percent, curly braces, name of my struct, in this case it is P1, this is the struct object, and then vertical bar, and then X colon 5.0. So this right side expression will result in a new struct which will derive its values from the P1 struct and update the value of X to 5.0. So the new struct will be X 5.0, Y negative 3.2. And I have to rebind that value to a variable P1 to have the value of P1 updated to these new values. If I try to update the field that does not exist, in this case I'm saying Z colon 5.0, this will result in a key error. So this is a summary of how you work with structs to represent information that naturally belong together, and we want names for each field that we want to represent. Here we are in our IEX console, and we'll start with creating a module. So I'm going to say module car do, and then do my def struct. And let's create 3 fields. Make, will set that to nil. Model, will set that to nil. And mileage, will set that to nil. And we end it, and we have created our first struct successfully. All right. So now let's create a concrete value from that struct. Let's call this accord, and we start with percent, name of the module, which was called curly braces start, and make, let's call this Honda, comma, model, let's call this Accord, and mileage, let's give it 56,000. All right, and here is our freshly minted struct called Accord. So now if I want to update the mileage of this Accord, I will start with percent, curly braces, name of the struct, pipe, and then I will say mileage, and let's put it 57,000. If I do that, a new value will be created, and notice that if I look for Accord, its mileage is still 56,000. So I do have to rebind this value to the same variable, and that's how I will get my variable updated. So now if I want to do a pattern match on this vehicle, I will start with percent and then write the module name car, curly braces, and then I'm going to say model, make, and mileage equal, which is the match operator, and I'm going to match it with Accord. And this is a successful match. That means my model will be bound to Accord, right? Make will be bound to Honda, and mileage variable will be bound to 57,000. I can also access the individual values of this struct using the dot operator. So if I say Accord dot mileage, it will give me 7,000. If I say Accord dot make, it will give me Honda. And if I ask for something, some field that is not available, for example miles, it will give me a key error. Similarly, if I try to update the field that does not exist, for example, I say mile 58,800, and this will give me a key error. So that's how we'll work with struct. In the next few videos, we'll again work with some example problems to consume structs so that we get more understanding.